Hello, guys. Welcome to part 4 of revision for the past paper, the 2022 past paper B. We're going to be focusing on the bonus question. So let's do that. Um, let me look. Let me see if I still have the project. Okay, I don't have the project anymore. Okay, just give me a sec. Let me send the project to myself via email. Um, duh. Oh, I can just clone it. Let me just go to my GitHub. Nope. GitHub. Is it on this one or the? Okay, it's on this one. Paper B 2022. Okay, there we go. I'm going to clone it inside CodeBlocks projects. Okay, so git bash, and then git. Okay, parent working directory. Do I have documents? Okay, there's documents. Let me clear the screen. So cd, move into the documents folder, and then within that folder, I want the okay, this is not the one. So cd1 drive, and then cd documents, and then there we go. CodeBlocks projects. Okay, so cd code blocks projects. Cd code blocks projects. Doesn't like the space. Okay, so let me do this. Code blocks projects like that. And then let's list it again. Okay, it has updated. So let me move into that folder. So code blocks projects. How can I keep saying no such file? Oh, code blocks. Code blocks projects. And then cd. Yeah, there we go. At the moment, there's nothing. It's an empty folder. So let me clone my project. Okay. I have to copy the link again. Git clone, blah, blah, blah. Okay, it's done. There it is. There's the question paper. Okay, so I'm just gonna leave that open for later. Then code blocks project. There's the project, then open it. Yeah, that should be fine. Yeah. Okay, so let me change that theme. Syntax highlighting. Okay, but KFT2 is the one. Okay, so we have this file, right? So let's see how many changes we have to make. There's quite a lot. So for the bonus question, we're gonna do the templates. So for the templates, it says make the entire UGA class templated and every member function must be implemented as a templated function. So what's the point of templates? Why are we doing templates? So the reason why we do templates is because so that we can have so that we can achieve generic programming. So generic programming is a concept where you make a function or a class become generic. So basically it can serve as sort of like a template. It can work with any data type in a way. That's basically in simple terms what generic programming is. It means that that function or class can work with any data type. So let me just show you right now. Let's create a new project. Yeah, let's create a new console application. New project. Let's say uh testing, just testing code blocks projects. That's where I'm gonna save it. GNU GCC compiler. Okay, so at the moment, as you can see on my management panel, the one that's it's highlighted in bold, that's the one, that's the project that's active. So if I were to click this build and run, it's gonna run the current one that I've built, right? That I've created right now. So it's gonna output hello world. So if you wanted to change, you just double click and you see, or you can just double click, yeah. You see, now paper B 2022 is the one that's highlighted, but we want to work on this one. So let's see a bit of generic programming in simple terms. So generic programming, like I said, generic programming is to work is to create. We want to achieve something called generic programming. And generic programming basically means that whatever function or class or struct, anything, anything of this nature, either a record structure function or or a class, can work with any data type, can work with any data type, can work with any data type. So in a way, we're making what we call a template. So it's just like a generic template. So imagine you had to imagine, for example, um, let me see, what example can I make? Imagine you have a document, you have copies that students need to fill in, and all of those copies are the same, right? But then on each copy, different information is being entered. So therefore, we can say that those copies are just templates. It's just a template for you to work with and manipulate it in whatever way you want to manipulate it. And you can add different information or different information, basically different data type. So in a nutshell, that's generic programming. So how do we achieve generic programming in C++? The syntax in C++ is that you just say template to say that I'm making a template. And then you just come up with some type name, remember that it now not only works with only integers or only doubles or any strings or only characters, it works with every type. So what you need to do is you need to say, okay, it's going to take in some type. So the keyword type name, it means that there's going to be a type that's going to be passed. And the type name, I'm just going to create and call it T. For now, I'm just going to call it T. T just for type. Or you can write it in full and say data type, or you can say type, but it becomes very complicated in your code. So we don't want to be typing it in full. So I'm just gonna type it like this and say template. You can also use the class keyword. It's Because remember, at the end of the day, when you create a class, you're defining a new type, right? So that's why that class keyword works there. So that's why I'm using the class keyword. So I can say class or type name, but class, I feel like a lot of lecturers say you should avoid the class keyword, because imagine you're making a class generic. So let's say the class is called UJ image. This is the class that you're trying to make, right? So now you have this class keyword and then that class keyword, and it becomes a bit confusing now. You start to think this is a full class that needs accessors and getters and constructors and whatnot, but no, this is very different. So we don't want to be confusing ourselves, so we're just going to use the keyword type name. And then there's the class UJ image. So okay, let's start with something basic. Let's not work with UJ. Let's make a function. So let's say void function that prints something. Print. I'm gonna call it print. So it takes in some type T. Remember that this T represents any type. So if the user passes an int where there's a T, the 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 T will be replaced with the integer. And then here's gonna put in int and so forth. So that's why I wrote T there. I just gave it a name that is some type, and this can be any type. That's what this means. Can be any type. So let's see what the any type is. So okay, let me see. Okay, okay, I don't like including the whole namespace, so let me just do this. See out. Yeah, that should be fine. And then I'm just gonna say output your value is, and then value, and then put an end of line or a new line character, right? So let's test it out. So let me call print and pass in a double. So 23.7, right? But with functions, it's a bit, yeah, it's a bit awkward. I think you have to, yeah, there's something that's missing. Yeah, let's see. Okay, it didn't. Let me see. Okay, it didn't. Oh, it's not. Yeah, it's not. What is this? I'm thinking about a different programming language, Java. With Java, you'd have to say here it takes in a double, something like this. Yeah, yeah. I was mixing up languages. Yeah, in C++, you just call it as it is, and then it's gonna infer everything there. So print a number, an integer, right? And then print a string. Hello world. And then print a character. Just taking a character. How do you print the character again? Do you say, you can say /u, right? For Unicode. Let me try something here. And then you pass the hexadecimal value, if I'm not mistaken. Let's say we want to output an exclamation mark, right? That exclamation mark. So it's a hexadecimal value of 21. I think you do it like that. You say 21 like this. Let me see. Okay, it's not. Uh, you say, don't you say, maybe say OX. Okay, still not the correct way, but yeah, let me see. Just put it as it is there. I wanted to work with the numbers themselves, but yeah, as you can see, it's generic. It's a template. You can put in you can pass in any information. You see 23, this is a double. And then this is what? Integer. It's a whole number. This is a string of characters. And then this is just a character. And you can even pass a Boolean too. And even say true. Then print false. You can literally pass any type. And remember that Boolean is basically a different type of an integer. Remember that computers speak binary, so they speak in zeros and ones. One meaning it's true, or there's little there's current. I would say there's an electrical charge. Remember that it works with what is this? Yeah, it's just basically representing the electrical charges in a computer, the Boolean. So in a way, it's actually integers. So don't expect to see true here. If you want to see true here, you have to put it inside double quotes or quotation marks so that it prints that string true instead of translating this thing into what it knows it to be, because it takes 1 as true and 0 as false. So as you can see, I can work with any type. I can pass in any data type. That's the whole point of templates. And templates become very useful when you want, let's say for example, you want to make algorithms, right? You want to make algorithms to that don't depend on the type. They work for all the types. So obviously I would make it a generic function and then implement my formula or my algorithm. So now let's use the template type name T for something else. Let's say we're creating a class, right? So class UJ image, and we both know that things like rows and columns are always going to be what? Integers. So just keep that in mind. Underscore columns. And then, okay, just normalize initializing your variables. Yeah, because if you don't initialize them, you might have an issue. Let me show you an example. Let's say, let's create a variable int num. And then I say cout num. I didn't initialize it, right? So I'm expecting the value of 0 to be there. You see, sometimes it gives you, sometimes it doesn't. In this scenario, it did give you 0 as the default value, but sometimes it might not even give you the right value. So just make sure you initialize it to 0. You can say is equals to 0 using the C style approach. So this is you initialize it to 0 like this using C style. Or you can initializing it using the C++ way. How do you initialize this? You just put curly braces like this. Then you say is equals to 0. This is the C++ way. I think it was introduced in C++ 11 or 14, if I'm not mistaken. This using initializer, the list initializer. This is called the list initializer. These curly braces. They are basically list, meaning that it's usually used to initialize an array or a collection of values or a list of values, but we usually call that, we use the term array for it. So yeah, it's a list initializer. So the nice thing about a list initializer, it can give you the right errors. It will tell you exactly what's wrong if something is wrong with your calculations or initialization or anything like that, or there was an overflow, it will complain. So yeah, okay, I think it usually helps with overflows, right? Let me see the int max value. The maximum value an integer can store, it's around 2 billion, right? Come on, why is this thing so slow? Let me run it again. Yeah, it's around 2 billion. So I'm gonna try to go beyond this maximum, right? How do I do that? I take that maximum and then I say +1, and then I output num. You're gonna see it does give you an error, a proper error. Okay, it doesn't. Yeah, but it should give you a warning. Yeah, I think it's a warning. Let me see. I think it's a warning. It's more or less a warning. Yeah, it's a warning. I think it's a warning, not a literal error. Yeah, you see, it's a warning. Integer overflow of expression int type results in. So it's basically telling you there was an overflow. You exceeded the maximum. So that maximum, since once you've exceeded the maximum, what it does, it starts from the minimum again. And what is the minimum? It's negative 2 billion. So yeah, that's the nice thing about the list initialize. Let's try it using the C style. And you see it won't give you any warnings. Okay, it does give you warnings. Okay, it does. But the C++ way of initializing is the one that's recommended. I also recommend you use that one. Yeah, maybe that. Yeah, I think in the previous languages it wasn't showing when you're using the C style. Yeah, I think since I'm using C++11 here, so maybe that's why. But yeah, so that's why you see this here. This is a way of initializing. This translates to saying underscore roses equals to 0. But then with this, if I do it like this, it's a more advanced way of doing it. And you can also do it using a constructor. You can say int num and then say it's equals to 0 like this. Num1, let's just call it num1. And then let's give it a proper value so that we can output the value. Okay, I don't have to see out. I can just call the print function and pass in num1. Yeah, as you can see, it works exactly the same way. So there's 3 ways of initializing. The one that I suggest is the list initializer, putting curly braces. So let's continue with what we're working with. So remember, rows are always integers. They can never be doubles or floats. Can never be anything like that. So let's create, let's say we have an array, right? Two-dimensional array of pointers, right? So remember that we usually create it like this, right? Say int pointer, and then we have values. So this means that this UJ image type that I've defined, it works with the two-dimensional array of integers. But then, as you can see, how do I know it's a two-dimensional array of integers? Because the two-dimensional array is of type int. But then now, since I'm using generic programming, I'm going to make it work with any type. So instead of working with only int, I remove and put the t there. That means it works with any type or any data type. So let's create a constructor called UJImage, takes in the rows and columns. Yeah, I'm going to combine everything inside of this class. I'm going to create the class and implement it simultaneously. That's why you're seeing this syntax. I won't do the header file not because I'm just demonstrating here. It's not a full application. So underscore rows is equals to rows. Yeah, just assume the rows and columns are positive. They are correct values. And then I'm going to have the destructor. Yeah, I'm just going to have something simple. So now my underscore values, two-dimensional array, I no longer say new int pointer like this. It still works exactly the same way. The only difference is that wherever I was using an int, I now replace that with a t, with some type. And this is the type that's going to be passed in by the user. So I'm going to replace the outermost pointer and allocate it. And then int r is equals to 0, r less than underscore rows, r plus plus. And then Okay, so I'm gonna create the, okay, I'm gonna allocate memory for every single row to be one-dimensional. So it's gonna be new, instead of saying new int, remember that wherever there's int, we put a T. It's now generic, it doesn't work with only ints. So underscore columns. And then for int c is equals to 0, c less than underscore columns, c plus plus. And then underscore values at that specific row and column is equals to some value, right? And the value that I'm going to take in, remember that we usually take in a default value called int of type int, right? Because why we're saying int, because at each coordinate it was of type int, but then now it's no longer of type int, it's of some type. It's of a generic type. It works with any type. So I'm going to have that there. And then we deallocate. Yeah, I won't worry about assertions and whatnot, just for the purpose of demonstration. So out is less than underscore rows, out plus plus, and then delete the columns dimension, and then delete the rows dimension, and then set the values to point to nothing, to null pointer basically. And then now I'm going to create a toString. So, okay, I'm going to need using standard string. And then I'm going to be using from the standard namespace the string stream. Okay, yeah, string stream. But then I also need to include both string and string. Okay, it's SS. It's string. Okay, so there we go. We have all the tools that we need. So I'm going to create a toString function. So it's going to return a string to string const. It shouldn't change the array. You should just output it. So let's output the array. So obviously I'm going to start by the rows, less than underscore rows r plus plus. There we go. And then I'm going to go through my columns. And underscore column c plus plus. And then I'm going to output, right? But I need to create a string stream ss, and then I'm going to use, you could initialize it, but yeah, let's just initialize it using the list initializer. Let's just initialize it to nothing. So by default, it's going to be equals to nothing, an empty string. And then now I'm going to put into the string the way I would usually use cout. So I'm going to say in, and then the value, that specific coordinate, and then followed by space. And then I'm going to insert a new line character. And then I'm going to return the string stream, but convert it to a string by using the .str function. So now it's going to work the same way this was working. But then let me see. I think you can do this. Let me see. Okay, you can't. It's only in Java. But I don't know why C++ didn't apply this. This would make a lot of sense, but let's just leave that for now. So obj image takes in rows and columns. So I'm just going to make it 25 by 25. And then the key thing here is the t value. What will be the t value? And now UJ image is not just an image class, it's generic. So it takes in some type. That's why we're defining this thing. This is what this thing means, this one line. It means that whenever you're defining that thing, especially for classes with functions, you can get away with it. But for classes, you'd have to be explicit and specify what data type. So you would have to, Wait, I think you can omit it. Let's see. Let's test it out. Let me say it's integers, right? I want everywhere to be okay, you can't with the class, yeah. So with the class, you can't, you'd have to specify what type. Remember the way we use this function. You're using it as if it's a normal function. We didn't specify, okay, you should take in, wait, but I think there should be a way. Let me try that like this. There should be a way to pass the type. Yeah. So this is where you pass, this is how you pass the type to the function. But for some weird reason, with the function, you don't necessarily have to. It infers the type. It looks at the type that you've passed in here, and then it determines what's going to be t now. And then t is going to be a double because you passed in a double. So you always specify the type after the name of the thing, whether it's a function or a class. So if you look at the function, it's called print, right? So what this means, this one line, it means that you're gonna use it the same way you guys were using vectors. It's generic. So remember that you have the vector class and then you put these symbols, right? The less than and greater than symbol. Then you specify that it takes in an integer, right? It's a vector of integers. Something like this. And then this vector would work with integers. Then you can also change it to a double. So it's exactly the same way with functions and classes. So we're gonna do that. So I need to be with the function, you can get away with it. You don't have to necessarily put the type there and specify that's going to be working with that type. So what happens before we go to put in the type, what happens is that, oh, it says, okay, you've passed double here. So now it's going to go to where the function was defined. Where there's a t, it replaces it with a double. That's what it does behind the scenes. That's why it's able to output that double there, because it knows that it's a double because you've passed in a double. And when you pass in an integer, it does the same thing. There's an integer. It's going to come here and say, oh, so this is an integer, and then this is an integer, and then so output an integer. So that's the beauty of generic programming. It works with any type. So now we want our array to be an array of integers, right? Because as you can see here, there it is. There's our class, and then now it should be fine. What's missing? Oh, I removed the variable num, so it doesn't know what's that. So now I'm gonna output the string representation. And you see, I'm gonna show you something very complex. So I want to output the string representation, right? So what I'm going to do is I'm just gonna remove this and just say output value. So remember, this function takes in any data type, even if it's a class, even if it's an object. Let me show you. So print and then obj image. It's gonna print the image because it works with any type. Wait, why is it complaining now? Okay, let me check. Oh, okay. So it's complaining about that. Yeah, it's complaining about this object. Oh no. Let me do this. I want the toString representation. Yeah. I want to pass in the string and then print that string. It should be fine now. I was passing the object and I didn't define the operator for outputting the stream insertion operator. As you can see, it's also able to print the object. But either way, it should print because it's just a string representation of the object. So you see, there's the two-dimensional array, right? So let's create a different UJ image. The same thing, but different UJ image. So of a different type. So now it's going to be working with characters. So what characters do I want? Let me say X is going to be filled with X's. And then char, and then obj image 2. And then you're gonna see it's gonna generate for that specific type. That's the beauty of templates. You see, now it's full of characters. And I can do the same thing with doubles. Let me say 3.4. But then now I need to change here and say it takes in a double. And then this is obj image 3, obj image 3. And you're gonna see it's gonna work with doubles too. There we go. There's 3.4s. It works with doubles. This is working because I wrote proper code and I understand what's going on. The two-dimensional array, I made it take in any type. We called it T. We gave it a name. It's called T. So every time you pass, you instantiate in this class or create an instance of this class, remember that you need to specify these brackets. And then you specify, okay, what is the type now? What is T? So what's going to happen is going to say, oh, T is now double because you've passed what? Double in there. So now where there's T's, it's gonna replace them with double. So it's gonna come here, replace with double. Come here, replace with double. Look at this T, it replaces the double. And then this T, it replaces with a double. So it's gonna do that everywhere. So that's the beauty of generic programming. Okay, with functions, you can get away with it. You don't have to put the data type like this and put the brackets there. You don't have to do that. But you can also still do it if you want to. If you want to remember that, okay, this is a generic function, you can do that. So that's it about templates. So let me do the project now. So I'm gonna close this project, and then now I'm gonna be left with this. So they said we should change UJ image. So there's a lot of things that need to change. So with UJ image, remember templates, how they work. Templates, it works, you include the things vice versa. So I'm gonna show you that now. So now, remember okay, it's supposed to be generic, but I don't know where is it going to be generic. That's the thing, because this UJ image, oh, okay, it's fine. So it can be pixels, it can be, okay, it's fine. We can just replace that UJ pixel and then we pass it that side. Okay, we're gonna have to check. They're saying make the entire UJ image class templated, and every member function must be implemented as a templated function. Okay, so we'd have to make everything templated inside UJ image. Okay, we're gonna do that, but I don't know how they want us to do that, given the fact that this thing is working with images. And okay, but we will see. Let's work with it. So let's make it generic. So let's go there on top of the class declaration and say template type name T, like this, right? Let me see if we have the stream insertion operate. Okay, we have this operate. Okay, remember this operator is not part of the class. I just want you to keep that in mind. This operator, it's a friend function. I'm borrowing my friend's abilities of outputting. So it's not really part of my class, it's not part of this UJ image. So this T doesn't apply to this because this function is not part of the class. So you'd have to define, you have to make it templated on its own separate, just like we did with the template function, with the generic function in that previous example. So it's going to be like this, templated. I'm going to say T1. And remember what we said, UJ image is now passed with those two brackets. Everywhere you see UJ image, you have to put those brackets. So what I can do, right, to speed up this process, I'm gonna, okay, I must remember to change this one to T1. I'm gonna explain why. So what I'm going to do is I'm going to say Control F, right, to find, and then to find this. Wait, is it Control? Let me see. It's Control Shift. No, Control F. I forgot how to change all of them at once. Let me think. Control F, right? Control F. Forgot how to change it simultaneously. So we're gonna have to change it one by one. So, okay, for the constructors, you don't have, let me see, but you still do, yeah, you still need to. But for the constructors, it's not mandatory for you to put the type there. It's not, you're not obliged to. The things that are most important is where you're passing UJ image. Because when you're passing it, you have to, and when you're returning it, you have to return it with a specific type. And then this now is generic. And then UJ image here is generic, right? And then let me build again. Is not a template. Well, it is a template. I know why it's doing that because I have the .cpp file. You see this .cpp file? That's the one that's messing up everything. So what I'm going to do is I'm going to create an empty file. Remember that remember that you're working with the made up type. And that made up type is not like something that you implemented, right? You didn't implement it like a class. At least with the class, if you implement it, you complete it, you put functions, you put this and that, it is a complete type. So you can create a source CPP, C++ source file or implementation file. But with templates, you're just passing T and you didn't, it's just some type T. You didn't like declare in a class called type T with methods and this and that. It's not a complete thing. You just said, okay, it just takes in some type. So C++ will have a hard time trying to compile that because there's no such thing as some type. So that's why we're going to create an empty file like this, and then we give it our own name. So the implementation file, when using templates, you don't have to, you won't use .cpp files anymore. It's .imps, or you can, for you guys, you have to use .imp. Imp standing for implementation, and then you save it into your project folder, and then select all. And the reason why it's white like this, because .imp file does not exist. We just made that up. So I need to tell the IDE to the IDE that anything that's written with a .imp extension, in any code that's written inside a .imp extension is gonna be anything that's written inside of that file is gonna be code, C or C++ code. How do I tell it? I go to editor because this is the editor. Where I'm typing code, that's the editor. And then I go to syntax highlighting. Syntax highlighting is this thing, it needs to highlight. And then I go to file masks, basically the files that it needs to highlight. And as you can see, if you check every file extension here, there's no .imp. So we have to edit. And if you check how the other files were added, you say, you put an asterisk like that to say every file, which that means every file. And then you say .imp. So you say, you put that asterisk there or that pointer, and then you say .imp. So every file that ends with a .imp, we should highlight it. That's what I'm doing right now. And then I press OK. and then press OK. The moment I press this OK, you're gonna see it's gonna start highlighting. There we go. It starts highlighting properly. It starts highlighting as if it's a source or implementation file. Okay, I'm gonna cut this line, it's too long. And then use another using statement here. And then cut that one, and then use another using statement. Yeah, this is better now. So now, as I was saying, it's an implementation file. Now the way you do it is vice versa. So you don't include the header file inside the .imp because the .imp is not a C++ recognized extension. It doesn't know what imp means. You won't be able to compile it. So in order for us to fix that, what we can do is we go inside the header file, and then immediately after all of this is done, we're done declaring the class. Now we include its implementation. So uj image dot imp, like this. It's always this way. It's always vice versa. You actually include in the header file. So let me see. You should remove that error there. It's not a templated class. Okay, let's remove this source file. Let's delete the source file. So let me view and then go to manager, then delete ejimage.cpp, and then build again. Okay, but it should be fine. So now we need to fix, let me see. T1, okay, we need to change this to T1 because this is its template. It's called T1. Pixels, uj const, uj image. And then inside the implementation file comes this very annoying thing. So everything that you implement, remember the whole class is generic. It works with generic type. So every time you you implement something of this class, you need to specify that it's a template. And then remember that DJ image is no longer just a UJ image with the type. It's a UJ image with some generic type. So all of this has to be repeated everywhere where you implement. Whenever you implement something that's part of the class. If it's not part of the class, like friend functions and all of that, you don't have to do this. If it is part of the class, then I'm afraid you have to implement. And then this returns an integer. And then this returns an integer too. And then this returns uj pixel. But we'll change that. We'll change that later because remember now it needs to take in a generic type, not just uj pixel. It should take in a generic type. So void, there we go. Then this returns a uj image reference, right? And uj image is what? Generic. So I have to put these brackets, these symbols, the less than and greater than symbol. Because it is generic. This class is generic. I need to keep reminding it. This is a friend function. It's not part of the class. So, okay, it's not part of the class, but you still need to make it templated. Remember, we called it T1, right? So we still need to use T1, but it's not part of the class. You don't put this and say colon, colon. You don't do that because it's not part of the class. So you just put that template and then you can call it T or T1, but I'm just going to call it T1 so that it doesn't get confused by these things. And then that's it. That's all you have to change there. You just have to specify that the object is indeed generic. Let me see. It returns a reference, UJ image reference. So UJ image, and it's generic and returns it by reference. And then it's also this one. It's supposed to return a void. So it's just gonna return a void like this. So basically what I'm doing is I'm replacing where there's UJ image with UJ image generic type of type T. But then it won't know what T is. So I would have to include at the top there and say it's a template. That's what T is some type. So I need to keep doing that. And then here there's no return type. So I'm just gonna declare it like that. And then here I'm gonna put a T there. And then done. And then this function, yeah, we can make the enforce range function generic. You can check types, maybe doubles and integers and whatnot. You can check different types. We can do that, but we'll do that later. For now, we're just starting with the important things. So of type name T. Okay, there we go. That should be fine. And then UJ image is generic, so I need to put those brackets and that T there. And I also need to specify where T is coming from. So T is some type, generic type. It's gonna be any type that the user decides to pass. And then there we go. Okay, we forgot to put it here too. Let's see if we have any errors. Why is it complaining though? Should have been declared inside. Why is it saying should have been declared? Whatnot. This is fine though. I don't know why it's doing that. Oh, let's see. Let me do this. It could be because of my main. So for my main, I'm just gonna do this. Select everything. Let me see. Isn't there an option here? Yeah, comment everything. Yeah, I want to see only the errors that are related to these classes. Oh, it's not a template. Oh, okay. I think I know why. It needs me to have the T type used in there. So obviously we're gonna have to change UJ pixel to T because remember the class works primarily with the array. So we need to change the type of the array to T so that it can be so that it can work with any values or any data type. And then I'm gonna use list initializers to initialize them to 0. Then a list initializer to initialize this to nothing, and that's how you initialize it. And then this is gonna be T. And then UJ pixel is now just T. Oh, and then here it needs to take in type T because UJ image is now what is this, generic. And then that means we won't have Yeah, I won't need this. Yeah, it becomes tricky now with templates because you can't say you're initializing this T value and then all of a sudden you're calling it, you're initializing it to UJ pixel. So you can't go there and say underscore values, it's pixels, right? Yeah, pixels, that's the array. You can say underscore pixels at a specific row and column is equals to default pixel. What you have on the left side is some type T, and what you have on the right hand side is usually pixel. And these two things are not equal. T is not the same as usually pixel. So yeah, this becomes a problem. So we won't initialize it like this. We're just gonna remove that constant there. And then now when I'm doing constructor chaining, now when I'm doing constructor chaining, let me see. But it won't allow me to take. Yeah, so now you end up not being able to have, what is this? This constructor with two parameters, because it wouldn't make any sense. Because now what are you going to initialize the default value to? The pixel. You could take some value of type T, but the question is, what is T? So I can't come here and say static const T. Default, right? Let's call it default something. Default. So it's going to be what default? What if I say the default is his thing is the default, what if I say the default is 2 and then I happen to work with a two-dimensional array of characters? You see, now it becomes a problem. So I'm definitely not going to have the parameter, the constructor with two parameters. This one, it's pointless. But the default one, this one, is going to be fine because we're not forced to pass any types. So I'm just going to have this, and then this is going to be T, some value T. Then I go down here to my constructor, my helper function for constructor. It's now taking some type T. There we go. And then this is no longer UJ pixel, it's T. This is T. And then yeah, that should be fine now. I don't know why the main is complaining though. It should be fine. Close. Okay. Everything seems fine here. EG class is not a template. How can you say it's incomplete? Because I do include it here. This thing can be weird at times. EG image is not a template class. What do you want now? It's not a template class. It is though. Oh, there are no that depend. I do get it though, but I'm gonna have to. They do depend. So it seems like this thing wants me. Okay, this is fine. It does depend. Okay, it's fine. Let me just do this then. Is it gonna be happy now? but you should always have it there. I don't know why it's moaning at me like that. Yeah, you see, now it becomes even worse. So yeah, you should leave it there. That's fine. Even though it's complaining saying you didn't use it, you didn't use the T or anywhere, it doesn't really matter. Can you say it's not a template though? Because you just create the type, you just use the keyword template, type name T, followed by the class name. Yeah, that should be fine. Let me just double check the textbook, but everything should be fine. C++, DS Malik. Generic programming, where is it? Templates. Why operator loading needed implemented in class cog type. Operator overloading. Okay, let me check exactly where the templates are. They're here. Okay, there we go. So templates, there we go. Yeah. So you say template class type T in it, right? And then followed by some declaration. The declaration can be a function, a class, or anything that makes sense. So let's see. We see we have some type here. Here they called it type, but T is short. And then, okay, let me see. Seems like they're using class keyword, not okay. It doesn't really matter though. It's one and the same thing. So there's class declaration. You see, I did it exactly the same way. So class, template class, and then class, and then you use it. Yeah, with this one, they're just taking in values like that. Yeah, it just works with the one fixed array. And then, yeah, you see, this is how you should implement it, you see. So you should say whatever the return type is, the name of the class, and then you put those, the less than symbol and greater than symbol. And then in between those symbols, you put in that T type, which is exactly how I did it. Yeah, it's exactly how I did it. Because if you double check again, this is the name, list type is the name of the class. And this is the source code, this is the implementation file, which is exactly how I did it. So let's see why it's pointing at me like this. Let me see. Let me go up there. Check. Okay, with this one, I didn't use constructors or anything like that. It was just a simple class. Let me see. Virtual const 0 virtual destructor. So implemented some type T print, prints out the list. Is item at equal. Mm, remove at. Okay. Retrieve at. Yeah, that's exactly how I have been implementing them. Functions that return something, they put the return type there. Followed by this. Let me see if this class does have constructors. No, it doesn't have. It has functions and operator overloading. Mm. Const array, blah, blah, blah. Is found, blah, blah, blah. Well, I don't know why it's doing that. Let me see. But nothing should change. Class and type name is the same thing. Class is not. Why is it saying what? This one was not declared in the scope. Was not declared in the scope. It is declared though. I don't want me to do this. That won't help. Should be like this. Why is it doing this? Could it be the compiler that I'm using? At this point in time, I'm not sure what the issue is. Could be the compiler. Most necessarily, you think it is the compiler. Let me see. Everything should be fine. Literally everything should be fine. Let me see if we have the toString. Okay, we have that pixels. What function? The operator of loading stream, the stream insertion operator that prints the pixels. Okay, so this should be fine. Yeah, that should be fine. Yeah, I think everything should be fine. It's either there's something with my compiler or something. Let me do this. Just press OK. Then build and see. Okay, seems like it's not the compiler. Oh, yeah, it is. Yeah, it is the compiler. I don't know why this thing is doing this. Paper projects modified. Yes. Yeah, let me reinstall code blocks. Yeah, I feel like the way it installed didn't install properly. Because now it's using the C compiler. And I'm not running C code. I'm running C++ code. So let me delete this code blocks first. So code blocks uninstall. Okay, uninstalled. Then I need to clear the cache memory, temporal temp memory. Code blocks, code blocks, code blocks. Where's app data? Then roaming, code blocks, delete, and local. Do I have code blocks? Nope. Yeah, that should be fine. Vista Minch W setup. Okay, it is downloading. Okay, that's fine. Yeah, I don't know why it was doing that. It's using a C compiler, and I'm running C++ code. So basically, couldn't tell what what that template meant. So it's like, okay, it's not a template because it couldn't understand what template means because templates are not in the C language. They're in C++. And I'm using a C compiler for that. So let's fix that. Let me install it again. And then there we go. Next. Image setup. There we go. Sorry about that. I don't know why it wasn't using the correct compiler. Okay, while that's running, let me remove any temporary files. And %tmp percent. Select all, delete, skip. Do this for all current items. Skip. And then prefetch. Then skip. And then this clean up. And then clean up system files. Yeah, this code blocks is taking its time. But it won't be long though, it's gonna be done soon. Delete all files. Okay, that's good. Yeah, I don't know why it was using the C compiler. Yeah, the GNU-GCC. Let's see if it did set it up properly this time. Uh, it still hasn't set it up properly. Okay, let me do this. I would have to delete again. I think there's something that I need to change. Let's change my environment variables. Or else this error won't disappear. So edit system variables, and then path, and edit. Okay, this needs to disappear. So I need to delete that. Then okay. And then while that's deleting, I remove cache memory from code blocks, roaming, code blocks, delete. Okay, program files. Okay, that's done deleting. And then I'm gonna fix a few things here. I need to delete this folder here. That one. Then it should be fine now. Okay, empty recycle bin. Okay, let's install it one more time. Okay, hopefully it's gonna be fine now. I think that was the reason why it was clashing. Okay, I need this. Okay, let's wait for it to finish. It's almost done. It's almost done. But yeah, we also have to convert the child classes to templates, to templated classes, because they inherit from a generic class. So yeah, we also have to convert them too. So better work now. Okay, seems like should work now. Okay, let's see if it does show. Yeah, now it's showing. I don't know why it wasn't showing. So I want the ISO standard. This one, G++. And then let's see with the editor if it still has the colors, but I don't think it still has. Yeah, it still has the default. So let's add the colors. So code, it's cp share config default.config, and then I'm taking from this theme. I must download the theme file again. Code blocks, theme download. And then I'm gonna download this file. Where is it? Themes, and then download. Okay, now we have the file, theme, open, and then I select all of the colors. Transfer, and yes, yes, save, yes, okay. So yeah, we're good to go now. So let's open code blocks. I was wondering why it wasn't like working, because templates are just templates. There shouldn't be anything difficult. It should be straightforward. So there we go. Yeah, colors are there now, but I don't like this one. I'm gonna go to settings, editor, and then syntax highlighting KFT2. There we go. And then I want to fix something here. Remember that the imp file we had told that previous code blocks to highlight. You see, if you don't do what it did previously, you see, you don't highlight, and you won't be able to distinguish when does the statement stop, when does it end. Everything is in black and white. So we have to go to file masks, and then I put the asterisk to say everything that ends with the .imp file. the imp extension. And then there we go. Everything in CodeBlocks is fine now. Let's try to build. We should be getting different errors now. Okay, seems like still complaining about that one thing. Okay, but at least now the compiler is there. It's now showing C++ here. Now we have the proper compiler. Okay, so now do, 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 do. The return type, what is it saying? The return type of class EJ_image is incomplete. What is incomplete? It is complete. There's nothing incomplete there. Or maybe it's the check. But that should be fine, man. It shouldn't be giving me such a hard time. Let me try the okay. Yeah, okay. The list initializer is available in C++11. Available in C++11. So we're gonna have to stick with C++11 and then no previous declaration. What is this supposed to mean? Because it's inside the header file and it's EJ_image. I'm honestly not sure what the issue is here. Because the issue starts here at number 36. Then we have these other errors. There are no arguments that oh, I need to pass the T there for that one. But yeah, all these errors they should disappear after I fix this thing. I don't know why it's not recognizing that this is a template. Type name T. Why isn't it recognizing that? Okay, so UG is not a template. Interesting. Still doesn't like that. Yeah, you just put that template type near the type name at T at the top. I don't know why it is giving me these errors. Yeah, I don't know why it's giving me these errors. Let me see. Let me see if I can try and figure out what's the issue here. Let's take in AJ pixel. Yeah, it must be of type AJ pixel. Okay, let's build again and see. What is the issue though? Because there's nothing that I see wrong here. Because if you check even in the textbook, even in the textbook, it's exactly how the way they do it is exactly how I'm doing it. And you see, when you do inheritance, you'd have to do it like this, and then that means the class that's inheriting from that templated class or generic class will also become generic. But we are not there yet. The issue is in this. The issue is here with UJ image. Okay, let me do this. Let me create a file. A header file. Let's call it test h, then underscore included, and finish. Let me see if this will give me issues too. Type name T class test. Okay, int rows maybe, and then T pointer values. Let's see if test will complain. Yeah, test doesn't complain. Interesting. So let's do it like this. What I'm going to do is I'm going to copy all of this and then just delete the header file and make it from scratch. This, copy, then delete UJ image. I feel like at this point in time, that's the best thing to do. UJ image. Let's see. Okay, I did add the .h. Okay, and then I'm just gonna add that there. Okay. And then the .imp. The .imp file. I'm just gonna cut everything, delete it, then create it again. Empty file, uj image.imp. Yes, I want to replace it. There we go. I don't know why it's still complaining though. Because this is how it should be. EJ image. Let me see. Let me see. Let me do this. Template type name T plus EJ image. I want to try and trick it and see if it's going to work. Okay, it's obviously gonna crash. Okay, it's still giving me the same error. Okay, let's do this. UJ image, UJ image, UJ image. I'm just gonna use a small letter I to see what's gonna happen now. Is it still gonna give me the same error or what? Okay, let me just do this and keep renaming it and renaming it. Because at this point, I don't know why it's complaining. Okay, this is a template, so I must put that T there. And I must rename this one. Rename. Come on. Rename. Okay, I also need to specify that this belongs to UJ, which is generic. I need to add the scope resolution operator. Or default is not created, so I'm obviously gonna need the, yeah, you see now it becomes very complicated now. So what I would do is so let me see. I'll just say now it becomes very tricky. How am I going to fix this? I don't know if I should put back. No, I feel like this constructor doesn't make any sense now. Yeah, it's the one with all three parameters, not the one with two. The one with two is fine. This one with three parameters makes no sense now. So instead, we won't worry about initializing it to 0. It's gonna be initialized there inside main CPP, and then here, yeah, I won't worry about initializing it. So all you just worry about is allocating. And then leave it there like this, and then read in the values from create new instances of the class. And then here, no more this. And then build. Where's the build? Okay, inside the header file, I need to remove this so that it matches with that. Invalid. Oh yeah. It was supposed to be like this. Default pixel was not declared. We don't use default pixel anymore. No matching. That means I didn't remove it inside of my header file. So there we go. Pixel was not declared. Oh yeah, I'm no longer passing a pixel, so I don't have to check ranges for that. Okay, there's few errors now. Mhm. Let me see. It's not templated. It is templated. Okay, let's just leave it like this and see now. What is it going to say? Oh, invalid use. Okay, so it is templated. So what I'm going to do is, let me do this. Let's put that back there. And then inside of our our header files for the classes that inherit, user image is now it's generic, so I must put that there. Then I'm gonna say template type name T, which is of type T, like this. That should be fine. And then renderer. Coordinate, renderer. Okay, that should be fine. And then these ones inherit from that. Then UJ is templated. So I'm gonna have to use a template, type name T. Oh no, I don't have to use a template here. Yeah, I don't have to. I can literally pass the type here so that it doesn't crash. It doesn't give me this error that I'm using a type UJ pixel. It's not a class template. I don't know why this thing is so annoying. It's not a template class. So let's also say UJ pixel here and see if we can get away with that. It doesn't want to. It's not a class template now, so okay, seems like it needs the header file. So what I'm going to do is include aj image.h. Okay, it also needs the forward declaration. So class uj image. Yeah, I should complain, but let's see. Let's just continue using T and then only specify the type inside main. Yeah, I think that's how we should do it. Not a template. Template type name T, right? Then do that, this. Then also make it a template here. Template type name T. Type name T. It is a template though. I don't know why it keeps refusing that this thing is a template. Template type name T. Expected class name. I mean, the class, I did include it in here. There's the render. Template, blah, blah, blah. No, that's fine. Just need to say template type empty. Then that should go away. And now, but UJ has been declared though. Class UJ image. Let me see. Render. It wants me to do this. Okay, yeah, it just wanted me to put the type there. Since, I mean, render isn't it's technically not generic. It just works with UJ image, which is generic. So it has that template declaration at the top. So that's why it forces me to also pass it when I'm inheriting from it. And then UJ image now is the one that's giving us issues. So here I would have to also put a T there. New, let me see. Do I also have to pass the type there? Okay, it comes this one. I have to say new, then pass that type name T there. Let me see if that's fine. Okay, I'm coming there. Shouldn't rush me this thing. Template type name T. And put a T there. Then I'm gonna do it for all of them, and then I'm gonna say void. Yeah, and then there we go. That should stop complaining. Continuous renderer is a type. Oh yeah, since I'm working with templates, yeah, I would also have to change this to so that it can be vice versa. Remember that with templates you create .imp files since it's not recognized. So let's do that. So let's do stochastic renderer .imp. Then I'm gonna take its implementation from here, all of it, then put it inside this file. There we go. And then inside stochastic renderer, I'm gonna say hash include stochastic renderer dot imp. Then now we need to do the other one too. So let's do continuous renderer. stochastic, I think it should be fine for now. So let's do continuous render. At the end of the day, I'm gonna need to include its implementation file .imp. Type name T, EJ image type T. Then change UJ pixel to T because that two-dimensional array no longer returns UJ pixel. It returns a point or a coordinate or a point on a coordinate of type T. So I would have to change this from UJ pixel to just T. And then here I would have to specify the type T and then template type name T and then T here. And then I'm gonna cut all of this and then create a new file, an empty file called continuous render .imp. Continuous render .imp. There we go. And then I think I can go here and start deleting the CPP files. Continuous render.cpp, ujimage.cpp, no longer using that. And then render, I also need to change renderer to renderer.imp. So the renderer file, this one, if we check the header file, it's now working with templates. So I would also have to convert renderer. So you have to make sure you convert everything anything that uses UJ image is gonna be it's gonna be sort of like it's also generic. So you also have to convert it to a template. You also have to convert it to work with generic, to be generic to work with any data type. So now I've converted the render, just cut, then cut this, render, delete, and then file, and then render.imp. Then paste. And then inside of the header file, immediately after the class declaration, render.imp, include its implementation. Unread the file. Yeah, there's no file called that anymore. And then let me delete this. And then we build. UJ image is not a template. It is a template. Or maybe it just wants me to do this. Say template, type name T, like this. Okay, yeah, that's what he wanted. And then obviously you need to make sure when you do this, you pass the type. Yeah, I must always pass the type. Yeah, so let's fix UJ image first. So inside of my UJ image, okay, there's no more constructor chaining, but as you can see, whenever you chain to a base class, remember that that class is no longer just a class. It's a generic class. Everywhere we use the name of the class must be followed by these three things: the less than symbol and that generic type that you gave it, whether you called it type or just T, and the greater than sign. So always those things they always need to be there. No matches for, let me see, draw. Oh, needs to be UJ image like this. And then I'll say T here. Yeah, there's a lot of things I need to change here. No wonder why it was giving me errors. No matching. When it says no match, no declaration matches, you need to check your header file, the way you declared it. As you can see, I renamed my UJ image to a UJ image with smaller I. Oh, that's why it was also complaining here. Yeah, that's why it was also complaining here. No such file. What is it complaining about? Continuous renderer. .cpp. It should be fine though. Everything should be fine. Continuous renderer. Okay, with regards to the UJ image, as you can see, whenever you use the UJ image, let's look at the renderer class. Yeah, the renderer class. So you don't have to be explicit and specify, put the brackets here. So you just need to put the template at the top and then you put class for declaration beneath. Then it's gonna be like, oh, okay, I know this class is a template class. So yeah, just remember that. Why is it looking for this file? Why is it looking for the continuous render? Oh, yeah, I still had it in my code. Okay, it's still, now it's working. So yeah, that's how you do templates. Yeah, I was just having issues. Yeah, but yeah, let's review. So let's start with the UJ image. You see with the UJ image, wherever you had a pixel or the two-dimensional array, you change that to a T so that the array works with any data type. It's not just an array of pixels, it's just an array of some type. So yeah, that's very important. And then everywhere and then you put the template type name T at the top to say that I'm working with a template now. And then everywhere you pass UJ, you also pass UJ image, you also pass extra information that states that talks about its generic properties that you need to pass in a type. So at this point in time, I'm not gonna pass in like a proper type, like for example, Boolean or double, whatever. I'm just gonna pass T so that it works with any type. And then we have, yeah, and then we have, yeah, that's pretty much it. Everywhere you see UJ image or the name of the class, you should add these three things: the less than sign, then the T, then the greater than sign. Everywhere used UJ image, everywhere. All places where you use UJ image, every single place. And then when it comes to inheritance now, let's look at the base class. So with the base class, remember that, okay, with the base class, it only needs the forward declaration. Let's not do, yeah, let's not do that. So remember what I said about forward declaration. You only use forward declaration when you are just taking a parameter. You're not accessing members of that class. You just do a forward declaration to say, okay, don't be shocked about UJ image. It's not something that I made up. It's some type and it's generic. Just know you're gonna expect a generic type called UJ image. So now it's gonna be like, okay, I respect that. I'm gonna wait for a UJ image that's generic. So you see inside the base class, you only include the forward declaration only. You only include the forward declaration, because if you don't, you're gonna have secular dependency issues. So you're gonna be re-including header files where you're not supposed to include, where you've already included them, or trying to include a file, the file that's inside the file that you're still creating. So just to avoid all of that, make sure inside your header file, your base class, you only do forward declaration only. Then you can see the renderer.imp. You can see the renderer.imp. As you can see, it's not really generic. It's just that we're working with a generic object, which is UJ image. So that's why I had to put the template type name T there. So just know whenever you make UJ image templated, even the base class and its children need to be also template made generic. You also need to use templates on them. Now you see the difference, right? With regards to child classes are not just taking in the UJ image, this type. They're also making use of the functions inside UJ image. You see, I'm getting the pixel. That's a function inside UJ image. I am setting the pixel. That's a function inside the UJ image. So if I don't include the header file, you don't know that these functions exist. It's gonna give me issues. It's gonna say it's an incomplete type, whatever. So let's do that. Let's just demonstrate. So type name T like this, right? And then class UJ image, right? Simple. Okay, it didn't complain, but it should be complaining. Yeah, it didn't complain, but it should be complaining. But yeah, just keep that in mind. I don't know. This thing has its own. Let me see. I think it's the renderer. Let's look at renderer. Okay, even inside render, I didn't put the header file. Yeah. Oh, it's working because, yeah, now I see why it's working. Why is it working? Because continuous renderer was not implemented. So let's do it here. Let me remove it here. Wait, remember this question only works with stochastic. It should, okay, it's not complaining, but as I said, don't do this. Don't include header files inside the base class. Only include the forward declaration because you're not calling or implementing any methods from that class. The classes that have to implement them, you have to include the header file. You don't do forward declaration. You must include the header file like this. And then everything should work perfectly fine. And let's see if the image is going to be generated again. Let's test it again. So inside bin debug, oh, it did write a binary file. Well, there's nulls here. It shouldn't be aimed, but yeah, don't have to worry about that now. So let me say CMD, right? And then let's see, it's called, so I'm gonna execute paper b underscore .exe and then transfer what's being outputted into a file that I'm gonna call image.ppm and then exit. That should be fine. And then now let's open the image. So we just want to see if the image still shows after adding templates. Yeah, the image still shows. As you can see, there's the image still shows. There they are, the pixels, the squares, the pixels. So yeah, there's the image. So yeah, that's how that's templates. That's how you use templates. So if you have any questions, just let me know. Yeah, that's how you do templates. That's pretty much it. Just make sure. I think you definitely gonna get this error about UJ image. It's not a template, but just ignore it. Continue typing and fix the child classes and the base class and everything. Once you're done fixing everything, deleting the CPP files, copying and transferring to imp.imp files, then you run it again, build it again. It should build perfectly fine. It should return status 0. So yeah, it should be fine. Yeah, so that's how you work with templates. Let me let me submit this, the answers, changes that I've made. Oh, so CD paper B underscore 2022. Then I need to clear and git status, then git add everything, then git commit. Just gonna say updated project. It's gonna be the message, and then git push origin main. And then git status should say working branches clean, working tree is clean, yeah. Then clear, then exit. So yeah, that's it for today's session.